Cool. Well, welcome Dr. Wortman on here. It's going to be talking about Bluetooth attacks, part two. Last week we did have him on here, I believe, and feel free to take it away, Paul.
Yep. Okay, so once again, I'm Paul Wortman, PhD, and today we're going to be talking a little more on the development side of Bluetooth. So last week we did some of the groundwork that hopefully will keep you from getting lost as we go through today. But the focus is going to be a quick review for those of you that didn't make it last week. Then we're going to dive into the painstaking world of Bluetooth device development and then come out at the end with some interesting tools I see on the horizon that I really want to play around with, as well as an understanding of kind of what they're doing as a mesh of everything that we've talked about. So who am I again? I'm a PhD, I'm a Bluetooth security researcher and a research scientist. Why are we here and talking about this? Bluetooth is a pretty ubiquitous technology, whether you're just war driving around for it, or as a hilarious solution to try to get around extra costs for patents in making cables. They are everywhere. And I know last week I said I couldn't really explain it better than it's replacing wireless wires, and I thought on that, and I think I've got a better way to explain it. The reason that Bluetooth is so important and that it's worth the effort to at least understand it and know what you're dealing with is that with any medium you're using to communicate across, it's important for you to understand how your information is being sent and how it's being processed on the other end. And especially with Bluetooth being as ubiquitous as it is. We're seeing it pop up from medical devices to home and security to sensors to be used in kind of all sorts of environments. It gets used as a method for tracking traffic based off of phones or the easy pass bits. You're using these types of machines everywhere, and because it's low power, it's very easy to kind of just throw, set, and forget. Now, from the review side, the most important part that I want to make sure we go over from last week is the GATT structure, because we're going to be talking about it again a little bit today in how we end up tackling and planning our development here. Now, for those of you that were here last week, you'll recall that essentially when you're looking at a Bluetooth low energy device, you've got a device structure, which in this case is represented by profile. And then that device can have a series of services, which themselves can have a series of characteristics, which can have a series of descriptors. And as you recall from last week, there's a variety of interfaces that you can use to interact with them. But for the most part, this is that higher level structure. Now, the new thing I want to talk about this week is advertisement, because how do we find a Bluetooth device out in the wild? We do it by advertising our presence through advertisement packets. Now, the main point of these packets is just to produce some simple information, what your address is so that you're identifiable, as well as a little bit of the services that you are presenting. We'll get into that a little bit further on when we start developing on a device. The other point from last week that is good to remember is that there are a lot of different solutions for hardware, for software. In the case of this research, we're focusing in on some very specific libraries. So the code you'll see later is using the MicroPython Bluetooth library. In terms of my own tool, Bleep, I end up settling on the BlueZ library for reasons that I wanted really small level granularity control, and I was finding some issues in attempting to use some of the higher level libraries that are out there. So that's great, but where do we start? Well, most importantly, we need to know how the Bluetooth system is going to work. And in this case, we're going to be essentially looking at Bluetooth as a state machine. The most important part of which is that there's a series of constraints. So as I was saying last week when we talked about this, the best way to think of a BLE device is a single processor computer. Multiplexing is probably the most creative way in which you'll get any form of parallelism or threading. The most annoying part about developing Bluetooth devices is the best way to make them work is to almost have precognition of what you're looking for. right? If you know the type of device that you're looking for, you can find its address, you can find its identification, which we'll get into in a couple slides. If you're looking for specific data, you know exactly how to parse it, how it should show up. These embedded BLE devices are not very good at reasoning out what something should look like, or even, frankly, enumerating large targets and tracking that information. But that is just kind of a nature of embedded systems. Now, the next thing that you need to keep in mind when we're talking about the Bluetooth state machine is that things have to be done in a very specific order. Again, it's a single processor system that knows one set of tasks very, very well. And if you start nesting stuff too much, or you start doing recursive system calls, you start hitting issues where you either get stalling, you start running out of memory. We'll talk about that in a few slides because that comes into play when we're talking about that GAT structure of looking at characteristics that are part of a service and all that. And as with anything, it's an embedded system, so memory, power, and stuff is limited. Now, one point I want to make now before we continue, because you'll see bits of it showing up in the next couple slides, is that there is a notable difference between a Bluetooth central device and a Bluetooth peripheral device. Central device is essentially like your server. It's going to be, frankly, it's going to act like a central device within a hub. The peripheral device is more like your headsets, temperature sensors, Fitbit, anything that is kind of an endpoint that's going to connect to a central device and feed information. Your phone is a great example of a central device. The reason I bring this up is that in a lot of the documentation that you do find, especially for MicroPython, is you'll see this difference of GAT-C versus GAT-S. For our intent and purposes, this is negligible. It's a difference between whether you're talking about the function call for a central Bluetooth device or a peripheral Bluetooth device. Yes, it's annoying. They do have different calls, but the functionality of the state machine underneath is essentially the same. So with that in mind, let's jump into just a simple act of scanning. So here, right, you're doing the same sort of Bluetooth functionality that you would expect off your phone. I'm going to scan for devices. I'm going to find the device I want. I'm going to connect to it. But because you're dealing with this BLE state machine, what you first have to start doing is configuring your function for scanning. So are you looking for a Bluetooth Classic or a low energy machine? How long are you going to be scanning for? Things like that. Once you start the scanning process, you'll hit a series of event calls. Now, in the documentation that I find for at least MicroPython, it's called an IRQ event, which I am guessing is internal request query or something of the like. Later on in the code, you'll see it mentioned in one of the comments. The main point here is that it is just an event. It's a state that can occur during scanning. What we're seeing here is that once you start the scanning process, you'll scan for some set amount of time, let's say 10 seconds. Every device that you find based off of those advertisement packets that I showed earlier, you'll perform some action. You'll call a callback function. So for those of you that were with us last week, you'll recall that interacting with these interfaces to perform actions requires you setting up your intent for a signal. So in this case, it's the advertising packet. And then you have to have a callback function, which is what you're going to do with the data returned from that. So for each device you'll perform some callback function, which could, be printing out the address, what have you. Once you are done scanning, there is the event for the scan completing, which can have its own callback function. So this is scanning, pretty straightforward, as it were. If we get into enumeration, it gets a little larger. And we're going to look at these as two halves, but this is where I want you to keep in mind that service and characteristic structure. So for services, we begin by selecting a device. Now, this is essentially done by selecting a connection number. Connections are kept as a list. We'll see later on in the code where you initialize it. But you're essentially holding a list of connections starting at 0 to identify each device that you've connected to. Once you've selected this connected device, you'll call a function for enumerating services. We'll get into it in a few slides because it will come into play with characteristics as well. But essentially, when you're looking at a BLE device, you can think of it as having a swath of sort of memory space that you're looking at. So the beginning of this device's space is going to be 4 zeros. The end of it is going to be 4 Fs, and services can kind of exist in that space. So generally, when you're doing these enumerations, you just brute force the whole space. Otherwise, you're precognizant of where exactly you want to search for a service or a characteristic or what have you. So the point is, when you start enumerating a service, you're going to look in this space. For each service you find, there'll be a callback function to perform some action. And once again, when you're done enumerating services, there will be an equivalent function. Next, when you get to characteristics, it's a lot of the same idea. Now, since characteristics are inside services, one thing you can do is you can say, okay, find me all the characteristics in the space of this known service's memory range, for lack of better terminology. Generally, the way you will see this done, especially if you use BTMon, which I talked about last week, to look at that HCI layer, which is the host controller interface. It's that software to hardware translation layer. If you use that while performing this action, generally what you'll see is get me all the characteristics from beginning to end. For small embedded systems, it's not terribly important where we aim it. The point is, this is kind of the state machine used to rule it. Now that you have an idea of how the state machine works, let's talk about how we label these services and characteristics and descriptors. So when you're dealing with Bluetooth Low Energy, there's essentially two main camps of identification. You've got your UUIDs, which there is a short and a long version. And then you've got handles, which are the representation of kind of those memory spaces. Now for UUIDs, you'll notice that the short only has 4 numbers, while the longer is a full 128-bit ID. How do they decide what 4 bits are in the short handle, you say? Why, it's the last 4 bits of the first 8. Why the standard has chosen that to be the shorthand, I don't know. As we all know, we'll never run out of spaces in the short handle, so this can't ever be possibly a problem. You're still early enough in the Wild West that it barely has consequence, but for those of you gray enough in the hair to remember when we would never run out of IP space, this is the same problem wearing new skin. Now, for the handles, as I said before, there's a start address and an end address. There can also be a value handle and a properties handle. Now, generally, the value handle is about 1 place away from the start of the handle. And the reason that I tell you that is that when you're interacting with command line tools, what you will sometimes notice is that the handles are different for what you asked for versus where the data that has the value is. And the reason for that is if we think back to that original structure, you've got the characteristic itself and then the buffer that holds the information. So that value handle is pointing directly to that buffer. Now, of course, there's more restrictions beyond this. And this is where we get a little bit into some of the more annoying points. So once again, that UUID space is somewhat standardized. The Bluetooth Special Interest Group, or Bluetooth SIG, has set this as the specific format for all BT-SIG formatted UUIDs. As you'll notice, it's only these 8 bits that are different. The shorthand is just these back 4, which is why the front 4 tend to be zeros. Some vendor-specific UUIDs are out there or are given, but for the most part, a lot of the space is unclaimed. So you can just make the UUIDs whatever you want. Again, the only confusion you'll get is if you say create a UUID with a short version, you may wonder where it's getting the rest of the numbers from. The other issue that you hit is, dear God, the people developing Bluetooth love abstracting everything. They will abstract your way in which you interact with all the tools. To be fair, my tool Bleep also abstracts the dbus API calls into something that's a little simpler to interact with. My issue with the rest of the Bluetooth community is that eventually you hit an H-file bedrock. Now, some of you may be wondering, what does that mean? For those of you that are familiar with coding in C, there are C files and there are H files. C files essentially will have all of the information, details of the function, what actions exactly are taken within it. H file is like your index for the C code. It'll tell you what the output of a function is, it'll tell you what the name of the function is, and it will tell you what the input variables are basically called in their type. But past that, it's a black box, up to you to figure out how it works. I have hit this H file bedrock no matter where I've looked, and we'll get into that later, as well as my cry for help with that. But that leaves us with one way to work on Bluetooth development. The only way to work on Bluetooth development, which is to find a working example and just start changing stuff and hoping that it works. Or if it breaks, figure out why it is it breaks. So let's dive into some of the painful parts of trying to develop Bluetooth devices. Starting with what I thought would be an easy example, I decided, okay, I need to get an Arduino that just creates a basic Bluetooth device. I need to be able to connect to it, read and write from it, stuff like that. Now, I was lucky in that one of my fellow researchers who does the injectile hide, which is some stealth hid research, had worked a little bit on Bluetooth. And so I enlisted his help in helping me get this ready, and we immediately hit some problems, which is one, defining some of this stuff is a little vague because the documentation is quite poor. The second is, if you don't read all the documentation, you don't always understand the weird behavior you see. So what we saw with the Arduino was that if we tried writing to a descriptor, even though I could set the file, the ability to allow writing, and it had a buffer that I could put info in and read out, if you wrote to it, it would cause the entire Arduino to crash. And this was hidden in a manual page somewhere, but fine. It got my feet wet. But I started hitting issues when trying to develop signals, which, if you guys remember from last week's talk, signals are essentially asynchronous um, messages that you're sending that you have to signal your intent for, and then have one of those callback functions. So I decided, okay, I'll remake it in something a little better. Let's move to the Pico W, which is a little more C-like, but still Python-y enough that it'll be quick to work with. And here's where I hit some more interesting issues. One, I couldn't nest calls a whole bunch. That's where I found, okay, well, really, I have to treat this as a single processor computer. I cannot try to have it, search a service, and then when it finds a service, call a nested call to search for characteristics, because the state machine that tries to run the processor can't handle that, doesn't know how to recover, and I'd end up stalling out my machine repeatedly. I would work maybe once every 10 times, but hitting reset 10 times to test one line of code is an absolute pain. The other issue you get is some of the information's kind of ephemeral. So because you're dealing with an embedded system, you've got a device that is trying to save memory as much as possible. So things like reading its own address became really interesting. And eventually I found a solution that would work by basically stopping the main loop or processor, which, if you remember from last week, we were comparing it to the idea that it's the engine of the car. And you listening to signals is listening to the radio, so you can't listen to the radio if the engine isn't on, because you need power to power the radio. So the way you would get around this is you would essentially start the Bluetooth device, so it would initialize an address, then you pause it, read what the address is so that you can then present it as output or debugging or whatever the hell you wanted. And then you would start the car again, which is very frustrating when you're trying to figure it all out. But hey, it's another good test bed. So from here, I decided that I wanted to work on something that was a little bit newer. So I decided to use the Realtek BW16. Now, it's about a $9 computer. Again, embedded systems are cheap. Restricted resources, it does require some planning. I needed to have, breadboard, wires, whatever modules I wanted to work with, and then find documentation. Now, documentation is relatively easy to find. Realtek does a good job of having kind of how-tos on how to get everything started and connected. What I did find, oh, that's the end of it. What I did find is that there was a prerequisite file that I needed to locate that was part of the micro Python's Bluetooth library called BLE advertising. And without going through the whole file right now, essentially what it does is it gives you some low-level dissection so that you can pull information out of advertising packets, you can tell what the address is, you can get the initial service handle locations, and it gives a demo so it shows you not only how it should read the information out, but also how you should expect the information to present itself, which is incredibly important. So here is where we're going to dive into code. I've tried to keep the rest as entertaining as possible. This part's going to slog a bit, but it's necessary to get into the bit at the end where we can start talking about tools that are out there and the other fun stuff. Now, once again, we are focusing here on a peripheral. It is separate from a central device. Please forgive the GAT-C versus GAT-S things that you will undoubtedly see. So, first thing to start with is advertising, right? Because without being able to advertise the device, we can't know it's there, we can't connect to it. So we import the Bluetooth library. We also import BLE advertising from that advertising payload file, as well as the ability to set constants. Why do we need to set constants? Because we need a way to identify the different events that are going to occur. These are all constants that are documented in the MicroPython documentation. You then need to set the flags for being able to read, write, or provide notify capability to any service characteristic or descriptor. Now, this is how you define these separate things. So what we're giving here as an example is essentially using the Bluetooth device as a UART. This is coming from some of the example code that you get that comes with the BW16 library. But we're going to show you the pieces for these different aspects so that we can kind of come together at the end and start talking about doing more interesting stuff with these. So this first point here is the service UUID. You'll see again that it's a set format that is repeated for those characteristics that are below it, except that the short UUID is incremented by 1. You don't have to do that. It is one of the few pieces of quote-unquote standardization that exist in Bluetooth development. But essentially what this shows is, okay, you're going to have a transmission line that has this UUID, and you should be able to read from it and get notifications. Remember that the transmission line in this case is the incoming line of information, and the RX line in this case is the display of information of what is going out from the device. I'm sure I've either mixed that up or we'll mix it up later, but that'll come into play when we're talking about reads and writes. Essentially, we're making a UART that will receive data, print what it's received, and send data out that gets written to a characteristic and then kind of out across the transmission line. The way that we define the service that has these is you have the UUID of the service along with a tuple that represents the transmission and receiving UUIDs. Next, we need to define the class of the device. Now, what we're doing here is we're stating that this device is going to be called MPY UART. We're also going to make sure that it's active, which I guess just means the BLE device that we've attached to it is working. Connections being set. This is what I was talking about earlier, how we track connected devices with a connection number. This is instantiates the list that tracks these different connections. We then create the payload using the advertising payload function from that prerequisite file, pass it the name of the device as well as an array of the service. So if those of you remember from last week, I talked about whenever you're presenting data or reading data from a BLE device, it tends to be in a hex array. Here we see kind of the same structure. It's not quite hex, but it's that array presentation of information. The next bit starts the advertisement of the device during initialization, or initializes the advertisement capability of the BLE class device. Now these two functions, send will come into play later. The main point to show it here is that you have the connections used. So as you can see, you're looking for a connection handle within this list of connections. It's mainly there just to show it to you. We'll come back to it being useful when we get back to notifications. The advertisement function, as you see, has an interval of 500,000 microseconds. And what it's going to do is use that advertisement to show that payload data that got set in initialization. The main function is pretty straightforward. We basically set this pin to be out because we're going to use it later to identify connections. We then create a BLE device using our class that we made. Substantiate a BLE device using the Bluetooth BLE constructor. Then using the class we made, create a simple peripheral and run the demo. That will end up showing a device. Congratulations, you can advertise things. What does it look like? Since I have one running in the lab right now, what you will see is that after a certain amount of scanning, you'll see a device show up with the name MPYUArt. Fantastic. So keep in mind at this point, you're only advertising your device. You don't actually do anything. You just say, hey, I'm here, and folks can recognize you. Now, the next thing you need to do is to be able to connect and disconnect from a device. So the first thing we import is time because we need to start timing stuff. The next thing is we create some changes to the class. What you'll notice here is that we're initiating an IRQ feature of BLE. So if you remember those event calls from the state machine, this is where they come into play. So what we have to do is we define an IRQ function that takes an event and data. The formatting of this is off, but for those of you that can read Python, it won't be too difficult. So what this is doing is it's saying if the event represents that central connect or disconnect event, which if you recall we defined initially during the advertisement part, it will either add the connection handle to the list of connections or remove it. The way it detects if it's connected is it just checks if the set of connections is greater than 0. And then while the board is running, we have it turn the light on if something's connected to it and off if something's not. Great, pretty straightforward. Now we need to move to reading. So reading will definitely require expanding that class definition as well as adding some stuff to that main function. So to start, you'll notice the IRQ statement now is a little more involved. So what we are doing is we're setting, the IRQ statement is not what's involved. What's under it is what's involved. So here we are setting the IRQ again. So that's going to bring in our IRQ definition. What's important is this, because this line here is where we end up registering the services. You'll notice that we're passing this UART service structure that we made earlier to GAT register services. And if you recall, this UART service is a UUID followed by a tuple of the TX and RX UUIDs. And what we get in return is a tuple of tuples that holds the handle for the transmission and the handle for receive. So what you have to remember again is that we have taken the UUIDs that we created and we've been handed back handles to represent these various capabilities. Now, past that, we define the ability to read an attribute based on a handle that we have, and that it will get a thing called data that will read from it, and it will return that data. We then create, and don't ask me why it's like this, it's the way it works. I hate it, but it seems to function on MicroPython. We then have to define a function that's whole purpose is to set what the callback function is going to be. And the reason for that is because I believe, if memory serves, or at least the way I think it makes sense, is that because the callback function has to be something that you can kind of globally point to, it has to work as a class variable so that when you set it, you always have a way to reference it, because you can't pass the callback function to the event that is going to use said callback function. It's very weird, and it just means you have to take this extra step to do it. So we have a function that basically sets a callback function. We then, in the main code function, set, okay, we've got a read action function that's going to take a data value using our read from attribute function, and it's going to print that data that it read from it. We now use the callback setting function to set the callback function for the class, and that allows us to read. So now writing, going to be very similar again, this time with just a little more flair. So once again, we have to define all this, except now we have to create an internal write callback function. Once again, here are your handles to the related UUID tuples. Then in the IRQ function, we have to add the GATS write event, which is going to get a connection handle and a value handle, because the way that you track what you're going to read or write from is you need to know the connection, so the device, and the handle, which is the value handle, not for the characteristic specifically, but for the buffer you're writing to. You then are going to use that handle to read the value of that handle, and if the value handle is the same as the RX handle, it will, and you have the right callback set, then it's going to call the callback function with the value that it read from the characteristic. Man, the UART example gets confusing, but this all works. So then what you do is you create your onWrite function that sets what the callback function is going to be. Then in your main function, you set a definition for a function that will print some information that was on the transmission line, and then write the information from the transmission line to the RX handle. You then set this function as the callback function for write, and it works. Now, notifications, you have a little more bit, a little additional consideration. So as you recall from last week's discussion, signals are a little more complicated because in order to capture a signal, we have to have kind of a thread running the car engine and a thread running the radio. The problem is when you have a single thread, or in some cases, like with Python, does not like doing multi-thread, you have to do some weird multiplexing in order to work around that. So the way that the BLE state machine does it is it essentially listens for all these things at different intervals. But the way you write it into the code is that once again, we set our tuples. We've got this send function where I introduce the connection handles to you again. The whole point here is that if you call the send function with some data, for every connection in the connections, it's going to send this information to every device that it's connected to, using the transmission handle. The way this works in the main function is while it's true and the thing is connected, this code will essentially print out a number every third of a second out on the TX line as a notification to our UART device. Okay, so that was a lot. Now, would I ask you to write any functional code from all those slides I showed you? Hell no, I'm not. So what I did was I put together a GitHub that has that code along with some other development code for the BW16 in it. Hopefully this sets enough of a groundwork that you can do fun stuff like attach a GPS chip to your BLE chip. Now, do you have more than a drawing? Yes, I do. I have the thing that I built that we're going to look at in a little bit. And essentially all it does is it listens for Bluetooth devices, associates a GPS location to it, so you're ready for your war driving goodness. Now, because we talked a little bit about the constraints of systems, and you sharp-eyed individuals may notice there are actually two BW16s on here, which is an unrelated project, but I have thought to expand the GPS system to using two separate BLE devices, one to just scan for devices since it's a dedicated job, and one that would just take the information spit out from that first one and assign GPS data to it, and essentially you have that one act as a tracker. Now, these are all fine and dandy ideas that we'll show at the end here. But first, before we get to the fun stuff, we have to go over the painful points of Bluetooth development. And yes, this is essentially my chance to whine and ask for help all in the same glorious move. First is For some reason, Bluetooth development seems to like to keep its freaking secrets. It is extraordinarily difficult to find good examples of stuff. That is why I presented what I did last week as well as this week. My hope is that you guys can use this information as a jumping point to be able to help with exploring Bluetooth, developing Bluetooth things, because this space really is a wild west. And I will show you at the end, I think, probably the two most advanced tools I've seen for Bluetooth research, and even they are kind of not getting past some of the stuff I showed you today. But the other issue is security seems to be this really ethereal thing. And what I mean by that is every database and library I have looked into, eventually I hit Bedrock, and all I see is a comment that says implement this later. So if anyone, for the love of God, if anyone finds good working examples of either security being implemented or pairing, please tell me. I am desperate for this stuff. We'll get a little bit into it with one of the tools because finding good examples in this space is surprisingly difficult. My second pain point is that abstraction thing I was talking about. Like I said, everything's a rabbit hole, man. I've tried going into finding as low level code as I can for how information is being kept, how some of these handles are decided, how why it is the Bluetooth state machine works the way it does, and eventually I just hit a wall. Um, it's a great place for reverse engineering if you love that sort of thing. But it is really difficult when you're just trying to get something that you think is a simple uh, example functional, just to find that, you don't know these little things that just aren't really publicly available. And my last point is, as I said, this is the Wild West. So almost everybody doing Bluetooth development is a cutting edge developer. Vendors will do things their own way. Even BTMon, when you're looking at some of the HCI traffic that passes by, as I'll show later on, some of that comes up as vendor specific, as being unknown. So, either someone needs to start cataloging it like they did with IPs, and we'll just eventually get a structure out of it, or, feel free to just kind of make it up as you go. This stuff is really wild, and it surprises me why there hasn't been more work in this space. So, what about the fun stuff? Okay, so the two big tools that I've seen that have piqued most of my interest are the following. So the first is Wall of Flippers. Most, if not all of you, should be familiar with the infamous Wall of Sheep. Same concept. This is a GitHub project that allows you to identify flippers and print them up in all shame. The reason I don't think this is that great is that all it is doing is it is dissecting those advertisement packets, which, as we've kind of gone over today, yeah, is a little bit of a headache, but it's not that difficult. If we take a look at the image, you'll see that all these devices start with relatively the same MAC address space. And this is an address space handed out by the Bluetooth SIG given to the Flipper folks. So yeah, if I can identify flippers through MAC addresses, great. But that might not always be the case. MAC addresses can be changed. So while a fun, interesting toy, even that is kind of not really all that far out the gate. Now, the one I'm really interested in is this one. It's the BLE Shark Nano. And the reason I'm interested in it is it looks like it combines a lot of the tools that we were talking about last week with the Wall of Flipper, and it puts it all into one nice little toy. Now, the part of it that I'm most excited about is that in the video on their Kickstarter, they showed the ability to start requesting pairing from surrounding devices. Now, the reason this is exciting to me is, you remember from pain point number one, is I don't really have a good example to model my pairing against. Now, as far as I've figured it out, I'm supposed to create an agent, maybe an agent manager. And whenever I am pairing with a device, I might have to make some separate thread that handles the exchange of even just numbers, just just your most basic, I want to pair this device. Great. The Bluetooth device shows these 4 numbers. Do you see the same 4 numbers? If everyone agrees, we're paired. Even just getting that example off the ground has been way more difficult than I would have hoped. But these guys look like they've got something that works. So I am super interested to see how it is pairing functions, because right now it is like beating my head against a desk trying to get it working. Now, the last one, of course, I have to promote myself, is my tool, or the Bluetooth Landscape Exploration and Enumeration Platform, or BLEEP. The point of this tool is to search for devices in your surrounding area and interact with them as low-level I/O, doing reads, writes, capturing signals, and the like. Is some example of what the printout looks like is here from my B-Sides Las Vegas talk last year. And we see here that looking at this device, we see some of the UIDs in that format that I was talking about. We see maybe some name information, version details. We see a 5.2 showing up, which maybe is the Bluetooth version that this device is running, since this would have been around the time that spec 5.2 and 5.4 were popular. We also see that it's a Zebra Technologies device, as well as this byte string that it just gives out to you. Now, the key point here is I'm just connecting to a device and enumerating these services and characteristics. I'm not doing any pairing. I'm not getting it to trust me. I'm not bonding to it yet. This is just what devices out there in the wild are willing to communicate. So, with that said, I'm going to open up for questions while I show you guys a bit of what this stuff looks like. So, feel free to ask questions and interrupt me as I'm talking. What I'm going to show you here is we've got that GPS setup that I told you about earlier. So, if we recall from the earlier slide here, essentially what I've got is I've got the BW16 connected to a GPS chip and connected back. The code itself is relatively straightforward. I'm not going to go over every inch of it, but you can see here we're defining some UUIDs and setting some callbacks to allow for notification of information. Our printout on the device shows, okay, here's some location information and the like. Now, if we want to connect to it, we can use Bleep to scan for devices in the area. The one that I'm looking for is that BLE GPS reporter, which we'll connect to. If we take a look at the serial, we can see it throwing up alerts for some of those events. That'll show you which characteristic is being read to, which connection it's from. All of this is code that is in that GitHub repository, so please feel free to make use of it. What we'll see here is that it has printed out that information. So we see here some known stuff like the generic attribute service or service changed. Some of it's unknown because it's a weird custom number that, while it follows the BT SIG UUIDs, it's not quite exactly that. We also see some of the other information for extra stuff I've added into Bleep. So I added the UUIDs for the system status and alert status that it can kick up. So if we generate the lists and read all the characteristics, we'll see it gives some positioning information as well as telling you that nothing is wrong with the status. That being all well and good, what does it look like when the system goes up against something that's a little more difficult? So another device I have here in the lab is that MPY UART that we got up and running. Now, what I did in this variation is I essentially made a kitchen sink. So I took that builder code that I showed you earlier and added in events for having a secure read capability and other things of the like. And what we will see is Bleep here is going to notice that some things may be connected on one level or another. If we take a look at the BT Mon traffic, which is that HCI layer communication, we see that we're getting events where the device is attempting to pair. You get a pairing response, but because there's no agent available and I can't confirm the passkey, it ends up failing. which also presents interesting information. What it looks like when it's supposed to work, I can't tell you because I haven't gotten a working version of that going. But the point in showing you all this is to tell you once again, this space is surprisingly open. Um, there are not there's surprisingly not a lot of information out there on specifics for Bluetooth development. Getting open source tools that will help you get a better look into these devices are surprisingly tough to find. Um, in general, there was a pause kind of in Bluetooth research. So about, that would be like a decade and a half ago, there was a white paper that came out that essentially said, look, most of the issues with Bluetooth, while it does have problems, are based on how things are layered on top of it. What does that mean? If you remember from week one, we were talking about that HCI layer and how it has a bit of its own kind of OSI model for it. Basically, the idea is that everything you're building up at the higher levels is where you're finding problems. Bluetooth is just the medium through which you are passing information. Since then, the 2023 ARMIS white paper did, I think, a much better job of approaching the standard, and they really came across with the message that, look, the Bluetooth standard is this Frankenstein monster of a bunch of stapled together protocols. So a lot of the issues that you're finding, especially with the bluffs vulnerability that we were talking about last week, has to do with these little edge cases on how these different protocols interact and the issues that you get when that happens. The tools that we see to this day are basically just taking apart advertisement packets, which you can do with Snappy, you can do with pretty much anything. There was a Flipper module add-on I saw that looks all sleek and cool. Let me see actually if I can find it. But all it's doing is reading those advertisement packets, which surprisingly, again, have some interesting information in it, but that's not really all that impressive. I can read advertisement packets. Cool. I don't think that's the fun stuff yet. I think getting into this low-level I/O, I think being able to map where these security functions and functionality are, which Bleep already does, is helpful. I think the trick now is taking a larger swath look at how security is getting implemented across these various devices. How can we essentially perform the same sort of poodle and rollback attacks we've done for Wi-Fi for Bluetooth? Um, and then, I can get into the more exciting stuff that we see coming up with Bluetooth specification 6, which gets into some interesting space. Uh, the one thing that I think is really worth the gander is the new audio capability. And the reason that I say that is what is coming up in the Bluetooth spec is the ability to have multiple listeners on a single audio source. And the benign use of that is that you would have sort of an audio tour in a museum or at a historical site, and you would just connect to the Bluetooth audio that has your language, and you could enjoy, the tour of the place. The thing that worries me is that that is capability, as far as I can tell, written in by the Bluetooth SIG. And the questions I have are pretty straightforward. Are you going to hear a ding every time someone connects? Because I would imagine at a historical site you wouldn't want that. So does that mean that the ability to ding when you have someone connect to your audio stream is configurable? And if it's configurable, can I set it to always be off? And if that doesn't scream eavesdropping to you, I do not know what else will. Now, to make it more exciting, another addition to the new Bluetooth spec that I've seen is that they are adding angle of detection math to the spec. Now, I don't know how to enact it, and it was some interesting trigonometry math that I'm sure might work if I remembered my trig better. But the idea is that you can now use angle of detection along with signal strength, I believe, in order to pinpoint locations of Bluetooth devices. Now, the benign thing being, well, Bluetooth and air tags are very popular. If I want to, advertise something and have someone locate a specific shirt or item I'm advertising, they should be able to locate it with a sort of sensor. The way I've kind of seen this in the current day is that if anyone remembers, Apple tends to have a lot of this stuff in their commercials. The multi-audio was in the AirPods that allowed you to share music with a friend. The location tracking I saw a bit more with, it was a commercial that had a bunch of like Mandalorians in cosplay, and it was playing some song about wanting to find all my friends at once. And it was using Bluetooth to locate people and all meet at one spot. This space is wide open. It's a wild west. I implore you guys to spend more time into Bluetooth research and Bluetooth device development. My voice is very tired and I'm going to take a break. Please ask any questions, or otherwise I'm happy to give you guys back your meeting.
Thank you, Paul, for that. Does anybody have any questions? I know I definitely do.
First of all, thank you for this session. It's been truly interesting. I'm not quite a established, let's say, security, research guy, but I do find it quite interesting. Um, I'm also part into software developing part, and also into low level stuff. So all this kind of stuff really find interesting now. That one question I had uh, was with that TX and RX part of the UUIDs.
Yes.
In those cases, is the TX UUID always following the RX one, or is it random?
You can pick it to be anything you want. You can put the RX and the TX in any order you want, as long as it is shown in those, as long as it's returned in those tuples. So I can show you the service and client examples that come with the BW16, because it does get confusing. But essentially, whenever you name the RX and TX IDs in this example, they're doing it in a very specific way, because you want both the service and the client embedded device to know exactly what they're looking for. And if you all share the same documentation, then everyone knows what they're looking for. But past that, whenever you're establishing the tuple for initialization, you just have to make sure that the tuple gets returned in that specific way. And I think this is the Arduino C code, which is separate from the one I was showing you. Hold on. But yeah, the short answer to your question is you can put them in any order you want, and you don't have to use those UUIDs. You can use any UUID you want. There are standard ones. So if we go back up to this look, right? Generic attribute service is just a known thing. That's generally where you'll find like the device name, or it has a flag for notifying you that a service has changed. Those are pretty much in the standard. Though really all they're looking at is kind of these 4 bytes, and the rest is just a format to follow. Otherwise, you can make them whatever you want. So for these ones that Bleep is labeling as Realtek BW system status, I just made that up, and in Bleep's Bluetooth constants files, I just added that UUID to translate to this type of service. Otherwise, you can name it whatever you'd like. Let's see, all the UART one, I left that. All the reads I started as leet read, and then just gave it random numbers. Go nuts. Have fun spelling stuff in hex.
All right, thank you.
No problem.
No, I had a question. So I know you mentioned for Bluetooth, it's some of it's kind of how it works is kind of vague, right?
Yes.
It it kind of reminds me of wireless. Is it in the same regards? From my understanding, is the way Bluetooth is kind of built from like system to system to system. Is it kind of just based off a developer looking at the Bluetooth specs that are out there and then developing it the way they perceive it?
Yeah. 100%.
So there's no like real standard like
there's a rough standard. So like if we take a look at does this BT capture have unknown? Yeah, here's a great example. So BTMon is a tool that you use for reading that HCI layer traffic. And that essentially should have all the standard stuff in it, right? But even for my device that just uses flags that are defined for it, except this is for the wrong one. But are defined for it. BTMon doesn't know what it is. It just says, oh, it's an unknown device flag. So yes, there is loosely a standard because you'll see that, oh, I know this is a Nordic UART service that works because I'm using the Nordic UART example. That's a known UUID. If you're looking at one of the weird UUIDs that I made up, it reports as vendor specific because I made it up. So yeah, it's absolutely the Wild West out here. And I'm surprised that spoofing and other things at a kind of service UUID level aren't more commonly found. And I don't know if it's just that building the devices is tough because again, some of the stuff is so vague and purposefully obfuscated from the public that it just hasn't gained traction. I mean, I don't know. That's the part where your guess is as good as mine.
most of this though, I would assume at least like on Linux and a lot of the open source side of things is the actual code base for how the Bluetooth and all that works. Is that at least open source?
Up to a point. So I went into it because right now my tool is written in Python, and I know eventually I'm gonna have to go to C. So I've kind of pulled out the BlueZ library, and I think for the repository I made for you all, I also added source code for some of the functionality because it was just such a pain to find some of this stuff and look at it. But even this is still pretty heavily abstracted. You eventually can get low enough to where the equivalent I could tell you is that it gets close to some of the dbus API calls we were talking about last week, but eventually you just hit all H files and you have to trust that the documentation you found is good enough.
Are those like binary blobs?
No, not so okay. Yes and no. So in some cases I found like hex files or blobs that represent the compiled firmware for the embedded system, which you could always go and reverse engineer, which is probably a worthy exercise, if not a boon on the community to have somebody do it. But for the most part, at some point, you hit bedrock, whether it's a blob, whether it's just an H file you have to trust, along with some pre-compiled something or other. Yeah. Eventually, something is hidden. And my read of the situation is that it is the Bluetooth special interest group kind of protecting itself the way that Zigbee has its alliance, that if you buy into, you get access to all the doc and all the information, all the help. But from the bit of exposure I've had communicating with the Bluetooth community, it seems like to get that information puts you under an NDA, and that would complicate my ability to open up Bluetooth to the public if I can't talk about the stuff I'm finding.
Yeah, I think the same goes with like wireless as well too, right? Like 802.11.
Yeah, I don't doubt it. It's all the alliance stuff where it's, if you pay in, we'll show you all the secrets, but you better not tell anyone. which again, Bluetooth has too. It's just there is a spec. It is about 2,200 pages, whereas I think because the Armis white paper did a good job of comparing it. I can't remember if it's Wi-Fi or the 802.11 spec, but in comparison, that one's like 600 pages.
And that's open to the public, I assume, right?
Yeah, I mean, you can just go to so the Bluetooth SIG website has its uses. It has spec documentation. It's got some information. It does have a what is it? Does it underdevelop with Bluetooth? I don't want to join the SIG. There is a developer labs or something. I've pulled it out repeatedly over the years. They have some kind of developing Bluetooth code that I can't remember where they hide it. You can find it Googling for it. But it is, again, really basic stuff. The stuff it kind of showed me was, here's how you interact with the dbus on a Linux device. Here's kind of what signals vaguely are. Here's how you can kind of double check yourself with a command line tool. They do have different code libraries for Apple versus Android, which is always a good idea. And then the other library I've seen them push towards that surprised me was Node.js. Which I mean, again, I guess again with the deployment and ubiquity of Bluetooth, maybe their thought is you'll control Bluetooth through a browser.
That's a weird one.
Yeah, I still don't like it, and I'm more upset with them because they decided to put out code for that instead of an updated Linux how to build basic Bluetooth device guide. Like the guide I found for them, if you find it, which is I think the Linux developer Bluetooth guide, it tells you like how to start scanning. It tells you how to connect. It kind of tells you how to read from a characteristic, but then leaves the rest up to you as an exercise. Which, yeah, man, if I have a bunch of wood pulp and, a manual on how to make paper, eventually I can figure it out.
Yeah.
But yeah,
it's kind of a shame.
It is. But it also means that the space is crazy. I mean, I'm the thing that shocks me, I think, the most is that I had enough time to develop this tool and nothing like it came out in the same time that I was working on it. And this was over like 8 years of trying to like figure out this stuff, hitting walls in trying to developing that Arduino. Man, I had a version of this that worked with that and everything was working great. And then I tried to sniff a smart bulb and all of a sudden I was getting authentication issues. And after searching and diving through libraries, I found, oh, my problem is the library I'm using doesn't actually implement any of the authentication. So the last year of work, I couldn't even have gotten this to work if I tried. So then I had to go and scrap the thing, find a new library that hopefully had the capability in there. And that's where I kind of settled on BlueZ because there is an API documentation for it. In fact, I think I have that somewhere in my bibliography references. But oh yeah, here's the Linux Developer Study Guide address, which will give you the resources for version 1 of the study guide. It's just all stuff like this that I wish it was better documented. I wish it was less painful.
I've heard some discussions about there being, regarding security around Bluetooth. You might have Bluetooth might be secure in one way, but it all depends on if the vendor who built the device actually added in those security protocols into their actual device that they're selling.
Yeah, and that gets me back to my first pain point, which is why if you find any good examples, please, for the love of God, tell me. because it is all vendor specific. It all depends on whether they decide to do it or not, or how they set it up. And as we kind of talked about last week, devices will act differently if you present yourself differently. So, like when I was working on Bleep on my research machine, most audio devices would not work with me, which is how I learned to differentiate headphones, because it would scream about A2DP or something like that, essentially the audio profile. And I found after I installed Pulse Audio on my laptop and I just scanned and tried to connect to a random address, I'd stolen my headset off of my phone and just connected it to the research machine, because all of a sudden I had audio capabilities. So devices were willing to just let me connect and interact with them.
So is there any way, I mean, it doesn't sound like it based off what you discussed, but any way where you can say, okay, I have this device, I want to check to see if it's got all the Bluetooth security features enabled on it?
No. Not
Okay.
not to my knowledge. I'm sure that the SIG has some special tool or whatever, but that's what I'm working on improving Bleep for now. Is I want something that can try to interact with it and say, okay, well, you say you have security, because we're on, I think most stuff should be 5.4 now, with 6 being the new spec. 5.4 was supposed to have security and encryption all kind of weaved throughout the standard. And I would love to find an example of it so that I could look at it and see how it works. Because the most that the documentation gets you is, so what is the get kernel BlueC?
Yeah, I'm kind of curious because I know there's a new federal standard that's coming around that's for like consumer products to have like a supposed like security rating on them, and I'm curious if Bluetooth is going to be covered in there and what will they cover and stuff like that. I know a lot of that has to do with like smart home devices. I know a lot of
Yeah.
smart home devices are Bluetooth enabled, so.
Oh, for sure. Dude, it took me hours to find a humidifier that didn't have a Bluetooth app attached to it.
Oh yeah.
Bluetooth is freaking everywhere, and
Yeah.
unfortunately, fortunately, hopefully it is under that, because that means maybe we'll get some clarity on actual Bluetooth security. But I would not be surprised if there's just nothing. Yeah, sure, they say it's there, sure it gets implemented, but how can you really verify that without
Is there like groups, like activist groups that are like coming in and trying to push this transparency at all?
That's a great question. And other than uh my own work, the 2023 Armis paper, and then there was a talk at Chaos Computer Club um this past Christmas and New Year's time span, that was looking at uh shedding light into the black box of RF, and some of it included BLE, which I still need to watch and look at. No, not to my knowledge. And again, part of the issue might be at least it feels to me that a lot of the Bluetooth research community is either pretty insulated, or because it feels so cutting edge. Maybe we're all being overprotective of our own work. I know it took me forever to finally make Bleep a public tool. Um, I know that maybe like 5 to 8 years ago, there was this guy doing some pretty cool research out of, I think he was from Belgium. I talked about him last week. He did the BTLE Juice and BTLE Jack tools. Fascinating stuff. And then I don't know what happened to him. Granted, I haven't looked in a while. I've been sucked into this. But if anything, I think the Bluetooth community just suffers from disorganization, maybe.
Yeah, it'd be interesting if they had like any sort of project out there, whether it was like a GitHub repo or some sort of website that would like catalog these issues. Maybe not on a per device basis, but maybe at least like on a per operating system basis or something like that. That would show these discrepancies.
No, for sure. And and I think because that was a question last week, is to kind of, is there like a scanner for this to just check if my device is safe? And other than writing your own and comparing like Bluetooth versions to known ones that might be vulnerable, there really isn't. And again, that's part of what I ideally kind of want to come out of Bleep. But even admittedly so for myself, it's difficult to get there. Just doing pairing has been a pain. I've again, like I was saying, I've kind of gotten to the point where I know I'm supposed to build an agent, and there's supposed to be an agent manager, and somehow the agent manager is supposed to show me a pin that I can confirm. But if we take a look at examples that are supposed to have that sort of thing, so is it DTH over BLE? I think the mouse is supposed to have security in it. What we end up seeing is a device where I think we define. Yeah, we just set configuration settings to true and set an authentication flag. But then digging into this, like, okay, well, what does set pairable do? Is this not the version of it that will let me go? No, it's the version of my research machine. So you can go into the sublibrary where this is coming from, and you'll find an H file that kind of tells you that there's this function and it can do stuff. But when you dig into it, eventually you just get to this leap of faith. Where just, yeah, I guess because I'm setting these flags, it just knows to work. Great, what do I do from a client side? Well, there's not really a client example. Here's the peripheral example for a mouse, but you have no idea how you would necessarily interact with this mouse in a way that would present the necessary pairing. If you do it on a phone and you're using like NRF Connect to connect these things, yeah, the pairing dialog shows up. It behaves properly, but trying to recreate that at a Linux level where I am trying to make the API calls to mimic that same capability, exceedingly difficult. And maybe it's I just haven't found the right documentation, or I'm not looking in the right place, or I'm missing some keyword that once I add it into my search, the stars will align and all that. But I've tried every avenue under the sun. I've dug through endless repositories. I've tried using AI to help write this and do the searching for me. I'm now doubling back to Nordic's development zone because it looks like they finally have something that's a little more useful um, for investigating BLE development. But when I first looked at it about a decade ago, it was not very helpful, and it was kind of had that join the alliance and we'll help you feel to it.
Got it. Well, hopefully we, at least at Null404, we can help spread the word, get some more eyes on this issue.
Yeah, and that's the hope. So hopefully between last week's talk and this week's talk, I've inspired somebody to actually dip their toes into this rat's nest of ridiculous BS, and help grow the space. I think there's a lot here. Some of the more interesting projects I'm working on is just fun audio stuff, getting audio profiles. So last week I talked about profiles, and we saw in the slide deck that the documentation from the spec says that this larger thing is a profile. I still do not understand what a profile is supposed to be. I get that maybe it's a way of having set configuration that you present itself to. I know it's necessary for doing audio, and I've tried just creating an audio sync, I think is the right terminology, on a BLE device, and it's surprisingly difficult. Some code seems to indicate that you use Bluetooth sockets to pass data, but I don't know that that's really BLE. That seems to be more Bluetooth Classic. One thing that I've seen is you've got like a couple libraries that maybe abstract it out a bit, but at some point I'm having to invest separate hardware to handle, I think, the I2C traffic that would allow the conversion of audio to something that the Bluetooth device can take in. I don't understand why I would necessarily need new hardware if I can have a Bluetooth headset just receive audio being transmitted from my device over Bluetooth. Because to my understanding, these buffers should be basically how you pass it. Sure, there's by default a 20 character buffer limit. You can alter that as necessary, but okay, great. I just pass it in smaller chunks. Is that Bluetooth standard? I don't know, because there isn't a great example for how to implement it. And Bluetooth audio is everywhere. Why is this so difficult? All right, I'm off my soapbox now. This stuff is
Oh, it's all
incredibly
good.
frustrating. I love the space. I think there's cool stuff you can do in it. Boards are cheap. It's only your time you're wasting working on this. But it's also incredibly frustrating. And hopefully this week's talk and last week's talk are just some more documentation that gets out there and helps build up the space and clarify it a little bit more and have it be more open source rather than something hidden behind an alliance and some hand waving magicry.
Well, does anybody else have any questions for Paul?
I'm curious if you'd encountered any substantial way to usefully use to capture Bluetooth traffic and then use that for reverse engineering. Is that something you've ever done?
Yeah, so there's a few tools I'd recommend for that. One is, again, if you're doing command line, BTMon is generally pretty good because you'll see everything being communicated across that interface. That's only really helpful if you're on a Linux device. I don't know what the Windows equivalent would be. Otherwise, Android devices generally will have an HCI snoop capability, which has been helpful in trying to decode some stuff or at least sanity check myself. I probably need to go back and do it again with my phone and see what traffic it's generating when I pair with one of these devices I've made. I've just been stubborn and using Bleep instead because I like suffering. But yeah, HCI log is what I'd recommend for Bluetooth because it will pop out a log that you can put into Wireshark, and I believe now Wireshark comes with the Bluetooth library standard. Otherwise, I believe it's a simple import to be able to decode HCI packets. And then for Linux, BTMon is pretty much the best you can get. But even there, right? I see that the packets are going across. I see that, the pairing response seems to tell me what capabilities the device has that are different from what I have. Here it is sending out the request with all 0 values. I mean, this should be a just works situation, right? Punch in a bunch of zeros and make it work. But then something on my end dies. And I think the most frustrating part is that the part that it's dying at is the part that's not well documented. Yes, doing the network captures definitely helps because right now I think it's the best method of illuminating what you are looking at. To your point, I probably need to go back to my Android, do some HCI snoops, and look at NRF Connect communicating to my devices because if nothing else, NRF Connect is a very good app for interacting with Bluetooth devices. It is just a more painful version because of how you have to present data and how you have to input, which is frankly where the effort for Bleep kind of started out of.
Oh, cool.
Sorry, that was a ramble.
No, it's all good. I just want to make sure I understood. Is HCI log a type of RF connect, or is that more of a Bleep thing?
No, HCI. Hold on, sorry. Could you repeat the first part again?
For sure. I was wondering. You mentioned RF Connect for using that. Is that something separate?
NRF Connect. It's an app made by Nordic that is the Nordic Radio Frequency Connect. It's a Bluetooth app for scanning and connecting to Bluetooth devices. It also has a log, somewhat similar to BTMon. So if you're debugging stuff via a phone, that is the best way that I would do it. If you're using Bleep, funnily enough, it does produce log files.
Cool.
I think I named them all BTI. Yeah, so it'll create log files that are based off of what it was running, if it had any debug issues. So in the case of debugging, you'll see some more of the information. It'll show you, for those of you that were there last week, it'll show you some of the printouts for looking through the e-trees for services and characteristics. It'll show you some of the issues it hit, along with some more detailed output relative to problems. Again, I tried to make Bleep pretty approachable. Yeah, and then I lost my train of thought.
You're good. Yeah, I appreciate it. You covered more than what I asked. Thank you.
No problem. It's what I'm here for.
Have you seen any benefits or any is Windows doing it any better at all or not so much?
I don't know as much about the Windows development space. Again, I hate to keep citing last week's talk, but in one of the slides when I was starting to introduce the dbus, I gave an excerpt from, I think it's the 2023 Armis paper. It basically says everyone kind of has their own solution. Again, it's that vendor specific BS. It depends on the developer and the alignment of the stars and the temperature outside that day, kind of what they chose to work with. So the interface that you use to interact with Linux versus Windows versus Android versus Apple are all technically different, but the general process at a higher level is the same. So in the case of like Bleep, all these dbus API calls are to structures that exist for all Bluetooth devices. I'm just having to go through this dbus avenue to do it. Whereas Windows has its own solution, and I don't know much more because I need to play around with making some Windows Bluetooth stuff because there's some interesting capabilities in that space that seem a little unique to Windows, but I can't recall exactly what. It's been like a year and a half since I dipped my toe in that pool. And then, yeah, as I was saying about the Bluetooth SIG examples, Android has its own library, which the names are on the tip of my tongue and I cannot remember them. And then Apple has its own variation as well. Like something stone and something else. But you see them sometimes in documentation. And it gets confusing if you don't know that because you're like, oh, well, why are they referencing two separate libraries for Bluetooth yet talking about them like they're the same? Because one is the Android library versus the Apple library.
Got it. Okay. Yeah, thanks for that.
No problem.
All right. I know we're getting late. It's getting late. What? Anybody else have any other questions for Paul? And Paul, I assume you could share out the slide deck as well.
Yeah, I'd be happy to share the slide deck. What I will probably do is like what I've done with other presentations, I will just make a public repo for it and just upload the slides there.
Perfect.
That way you all will have the slides for last week's talk and this week's talk. And then I'll need to go searching for the YouTube links, but I'll add the YouTube links and the readmes for these as well. And then because I have to keep plugging Bleep, if you do look at Bleep, highly recommend you look at the README file in raw text because I did not write this with Markdown in mind. But the more important thing is at the bottom, I've got links to slides for various places I've presented Bleep at, as well as the YouTube video for some of the talks that have been published.
Cool. Perfect. All right. Well, we will call it a night. I'll stop streaming and thanks again, Paul, for giving the talk